Find the vertex and intercepts for the following quadratic function. And we are given f of x is equal to x plus 3 squared minus 9. So let's start by recalling the form of the quadratic function that we're given. So let's recall that if we have a quadratic function, f of x, or even y, is equal to a times x minus h squared plus k, and this is where a, h, and k are all real numbers, we know that we can find the vertex using the h and k coordinates. So the vertex is the turning point of the parabola, our quadratic function, where x is defined as h, and the y-coordinate is defined as k. So we're using, there's your x-coordinate, and here is the y-coordinate. So we're going to be using this with our given function. So let's see here. We are given the quadratic in the graphing form f of x is equal to x plus 3 squared minus 9. So the big thing that we want to notice here is that in this standard form, we have a minus h. And in our given function, we have plus the h, or plus 3 here. So we're going to start by just rewriting this function to match the standard formula. So we can rewrite this as x minus a minus 3 squared plus a minus 9. So now it's matching that form. We can see that we have this x minus h, and we use parentheses here too for safety, squared plus k. So in rewriting it like this, we can see that therefore, like the x-coordinate, x equals h, is negative 3, and our y-coordinate, which we know is defined as k, is equal to minus 9. So therefore, our vertex is the coordinate point x, y is equal to negative 3 minus 9. So now we have our vertex. We want to go ahead and find the intercepts. So we'll start with finding the x-intercepts. And we want to recall that to find an x-intercept, we're going to let y equal 0 and solve for x. So we're going to have our given expression. We have x plus 3 squared minus 9 is equal to 0. And now we're ready to go ahead and start solving for x. So the first thing I'm going to do here is we'll add 9 to both sides of the expression. So we have minus 9 plus 9 goes to 0. And we are left with x plus 3 squared is equal to 9. And now we've set ourselves up for the square root method. So if we take the square root of both sides of our expression here, this is going to leave us with x plus 3, because we see on the left-hand side the square root and the square cancel each other out. And then since we know 9 is equal to plus or minus 3 squared, the right-hand side leaves us with plus or minus 3. And so we're ready. We can go ahead now and subtract 3 from both sides of this expression. So we have positive 3 minus 3 combines to 0. And we're left with x is equal to negative 3 plus or minus 3. So we're going to need to consider the two cases here. So let's actually rewrite this over here. We've got x is equal to negative 3 plus or minus 3. And we'll have a positive case, and we'll also need to consider the negative case. So the positive case is going to be x is equal to negative 3 plus 3, which leaves us with 0. And in our negative case, we have x is equal to negative 3 minus 3, which is negative 6. So we can leave our answers like this. This is beautiful. Or we can write them as ordered pairs. So our first case is x is 0, y is 0. In case 2, we found that x is negative 6 when y is 0. So these are our X-intercepts. And then last but not least here, we need to go ahead and find the Y-intercepts, or Y-intercept. There's only going to be one Y-intercept. So very similarly, we're going to go ahead now and let x be equal to 0 and solve for y. So we have y, our given function, is 0 plus 3 squared minus 9. So this is equal to 0 plus 3 leaves us with 3 squared minus 9. And we know 3 squared is 3 times 3, which gives us 9, minus 9 is equal to 0. So therefore we can write our answer as y is equal to 0. Or if we wanted to write this as an ordered pair, we can say that when x is 0, y is 0. And that is our beautiful final answer.